those of you who think I've been going too fast, now I'm going to go too fast. So stick with me. There are 5 ways to prove parallelograms are parallel. So if you have a quadrilateral, there are 5 ways to prove that that quadrilateral is a parallelogram. Okay? Number 1. Explain this one to me. What is that one saying? What does this mean if I draw it that way? If I draw it like that, what does that mean?
The sides are congruent.
Okay, so opposite sides are congruent. So is that a valid way to prove that shapes are parallelograms? Yes, it is. Okay, number 1. Number 2. What does that picture mean? Nope.
Sides are equal.
This one means opposite angles are congruent. Okay, next one. What is that picture telling us?
Alternating.
This picture is telling us that the diagonals bisect each other. The diagonals bisect each other. Diagonals bisect each other. I don't know what happened, but okay. Okay, there are 5 ways, so we have 2 more.
Are you even laughing about what I said?
Okay, what's this one? How is this one different than the first one? Yeah, this means congruent. This one means parallel. So this one is just the definition of a parallelogram. Opposite sides are parallel. Okay, what do you notice about all of these things so far? Are they all properties that we've learned today?
Yeah.
So the only property we have learned today that doesn't prove shapes to be parallelograms is consecutive angles add up to 180. Because there's other shapes that do that. So that's the only one that you can't use of the properties we learned today. And then, of course, we can use the definition. Now, here's the last way. This one's weird. Tell me what this means.
They're parallel and they're equal.
One pair of sides is parallel and equal. Good job. One pair of sides is parallel and equal. So make sure you know those 5 ways to prove parallelograms are parallelograms. And guess what I'm going to put on this blank right here? Can prove with one pair parallel and congruent. So item number 5 on this list on your purple paper is the one we just barely learned. That's a way you can prove them as parallelograms, is if you have one pair that's parallel and congruent. Okay, just a few examples, and you'll have 5 minutes to work, and then we'll be done. Keely? If you're wondering what I wrote on the last line on the purple paper, it's just this right here. The last line on the purple paper is this little thing right here. One pair of sides parallel and equal. Okay, last set of examples. Can we prove these are parallelograms?
Yes.
Okay, Okay, number 1. Can we prove this is a parallelogram?
Yeah, buddy.
Can we prove this is a parallelogram?
No.
Why not? No, this one would be a kite. Notice how it's not opposite sides, it's consecutive sides. Consecutive sides are congruent. Well, things aren't always what they look like, so. Okay, can we prove this one is a parallelogram? Come on, you guys, can we prove that this is a parallelogram? How? Which of the 5 reasons is it? Which, Angel? Not quite, because that pair is, but it doesn't say those are. What kind of angles are these? Joe, you helped me out with these before. What kind of angles are these right here? Alternate interior. If alternate interior angles are congruent, what does that tell me about these 2 lines? If these angles are congruent, then the lines are parallel. There's the word I'm looking for. So this is reason number 5. What is reason number 5 that we just barely learned on this paper here? One pair of sides is parallel and congruent. Okay, you guys have ruined the fact that you got to not stay after a minute. You're back to staying after a minute, and it might be longer because you've flaked out on me. It's just all the little talking, especially Joe and Spencer. Blame them. But it's not just them. But there's other people too. Okay, you're making it worse. This is because we have one set of sides that's parallel and congruent, because the alternate interior angles tell us that those sides are parallel, right? Okay, let's do another one. Yeah, here's a good one. Yes or no?
No. Is it what? Yeah. Is it parallelograms? Opposite.
Yeah, we're trying to prove. Is it a parallelogram or not?
Yeah. Well, yeah. I don't think so. I think it is.
This one's a hard one. The answer is no. If you remember our 5 reasons again, we have opposite sides congruent. Do we have both opposite sides congruent? No, just that one. We have opposite angles congruent. Do we know anything about the angles? No. We have diagonals bisect each other. Do we have any of those? No. We have opposite sides are parallel. Do we have opposite sides parallel? Only one. That's not enough. And we have one pair is parallel and congruent. That almost applies, but what's different? In order for it to be rule number 5, they have to be the same set of sides. The same set of sides are parallel and congruent. If it's not the same set of sides, then it could easily be a trapezoid, because those would be parallel and those would be congruent. So that doesn't prove anything. Okay, your assignment is on page 451 and 457. Instead of holding you after for a minute and a half, or a minute, or however long you were supposed to be held after, I've decided that you can leave. 2 conditions to leaving today. Number 1, the bell has rung. And number 2, you have done at least 1 problem on an assignment with your name, the date, the page number, and at least 1 problem on your assignment done. If you don't have a book, then you better find somebody with a book. If you don't have a book, you better have an iPod that you can bring up the problem on your iPod. You have to have at least one problem. More would be preferable, but at least one problem from page 451 done from your book assignment in order for you to leave.